Check, are we live? Fantastic. Good afternoon, everyone. It is time for the last official time slot sessions of the day, except for PostCon. How many of you are going on to PostCon? Okay, so a lot of troopers here. Appreciate your sticking it out. We're going to be walking through a bunch of things that you can do about optimizing your storage environment, especially focused on 2013 with RBS and shredded storage. Just to get started, I really feel like you are all the fantastic troopers who I've been thinking about every year since 1976, which was the first time that I recall watching a Winter Olympics. Because late in the whole Olympic cycle, there's always this moment where when I was a kid, it was Jim McKay, and all the athletes are converging on the closing ceremonies, and everyone's having a party, except for, meanwhile, there's the cross-country teams out finishing the, 150K race while everyone else is having a party. So you guys are the cross-country troopers who have made it here for this session. So thanks very much. So, by way of introduction, my name is Chris McNulty. I've been working in SharePoint for the better part of the last 14 years. I am based in Boston, Massachusetts. I am a SharePoint MVP as well as a number of other Microsoft designations. I live just outside of Boston with my wife Haley and my 3 kids. I went to Boston College and Fairfield University, and I am really psyched to be here again at SharePoint Conference. It's been a fantastic week. We've heard a lot about Microsoft's commitments to Office 365 and to the on-premises platform. What we are covering today is going to be principally focused for on-premises environments because that's the place where we're configuring storage. So, really enthusiastic about what we're covering here. My background is largely drawn on financial services, IT, and consulting. Prior to joining what was then Quest and then Dell. And as some of you in the community know, I am prepared to make an announcement shortly as to which company I'll be joining next. But I see some of my colleagues from Dell here in the room, and it's just a lot of fun to be out here. Just a little bit of introduction. As I said, I am from Boston, Massachusetts. How many of you have never been to Boston? Great, that's my house. No, that's my wife, Haley, and my 3 kids, Rachel, Nate, and Devin. Devin's the oldest one. She's at NYU, so she wasn't with us on this trip. This was actually at SharePoint, the SharePoint Conference in London last year. What will we be talking through today? Well, just to get started, we're going to set the landscape by talking about how the demands and responses for storage have evolved since the first release of SharePoint 2001. We are also going to be taking a look at, in specific, shredded storage and RBS. There are a lot of things that you can do. I'm going to not do that again. Because I know it's bad for you on the ears. If I'm standing right in front of it, it's really bad. That hurts. So I have an incentive to not, I'm going to get zapped if I do that again. Shredded storage and RBS are the 2 things that we're going to talk about, how they work, why they're there, what to be aware of in adapting to those. And then we're going to draw upon a bunch of research. At Dell, we championed a lot of information that we have shared with the community about how we can stress test storage environments under a range of loads and circumstances to figure out what makes the most sense for RBS and for shredded storage. We're very happy to participate in the community with some other companies, notably Metalogix and AvePoint, who have also released data on this, as well as working closely with the Microsoft product group. We're going to present all of those results, and you can figure out what may or make sense in your environment. And then talk through how to take that and optimize your own SQL environment to perform adequately. File input-output on a SQL server is the most important predictor of performance for on-premises SharePoint. We can talk about memory on web front-end servers, and we can talk about processors on app servers, but input-output operations on SQL are the most important bottleneck to be monitoring. And lastly, since we are recognizing that it is a cloud world, we'll talk about how some of these things, and particularly shredded storage, matter in Office 365, but that'll be a fairly brief thing. A couple of rules of governance for today's presentation. Performance testing isn't really conducive to demos, so we're not going to actually run through the tests here in the lab. It takes about a week. Obviously, Office 365 is going to be mentioned. How many of you were in Bill Baer and Chris Given's session on Tuesday? Okay, I know there's some repeaters. So there is some overlap in content with these sessions, but I spent a fair bit of time resifting it and remixing it to give those of you repeat guests a new performance. And again, best way to get in touch with me anytime, and I'll have my contact information up later on as well, through my Twitter handle @cmcnulty2000. So let's get started. Let's look at SharePoint storage, how it has shifted and changed over the year. We know what we're looking at today. We have a profusion of SharePoint sites. Enterprises that may have begun with a single server departmental build usually have multiple web apps and multiple farms everywhere. More files, the content glut, the content explosion is definitely out there. More people coming in. And a lot of the reason for that is driven by the way Microsoft has taken its cross-browser support, OneDrive for Business, Office 365, a whole bunch of ways to extend the range of SharePoint out to new users. And at the same time, those users are creating more and more content than ever before. There was an AIM survey that came out last year that was talking about volumes of content growth. And content has grown in many organizations. Their farms, the rate of growth of enterprise farms has slowed down somewhat. Some of that is being drawn off by Office 365 and cloud-based solutions. And some of it is about the maturity of the platform. We heard Jared talking on Monday about the level of adoption that we're seeing across the board is really quite significant. But the content volumes continue to grow at a skyrocketing pace. And let's take a look at kind of how SharePoint has adapted to those demands. Looking at this over time, the first version of SharePoint, in 2001. Oh, by the way, I have one or two giveaways of an advanced edition of my book on SharePoint 2013. So if I ask a question and you get the right answer, I'm not going to zap you with the mic again, but just come up and see me afterwards, and or run up here mid-session and we'll get you a book. SharePoint Server 2001. Anyone recall what the code name was for that server? Well, usually I call on people, but yes, Tahoe. Thank you very much, madam. File storage in SharePoint 2001 was handled in the web storage system, and it was based on Exchange, and there was a little bit of metadata that went to a database, but it largely was an Exchange paradigm for how we addressed content. SharePoint's Portal Server 2003 was the first place that we saw SQL brought up, and when we moved to SQL Server, we saw the rise of blobs. All file content that users were uploading to document libraries, the decision was made to store that directly inside of SQL Server content databases. And when Microsoft did that, they mapped the file type to a SQL Server primitive called image. Image was limited to 2 gigs. So by the way, that's the reason why now in code, the maximum file size in SharePoint is 2 gigs. But 2003 is the first place that we saw SQL in and made the decision to keep files completely inside content databases. And when SharePoint was small, that decision made an awful lot of sense. But when we look at these blobs, it's important to remember that in most environments, they can represent over 90% of the files that are the data that's taking up space in your content database. When a file is uploaded, it's serialized into the ones and zeros, and it's dropped into a column in a content database. In SharePoint 2010, every version of a file generates a full blob. So if you have versioning in a collaboration site, every document that gets saved is going to go in sequence. So if you have a 1 meg file and I edit it 3 times, I now have 3 megs of content in the database, and so on and so forth. SharePoint 2013 shifts this somewhat, and we'll explore this in depth, but just understand behind the scenes, in SharePoint 2013, no matter how you configure it, every file save generates at least 3 blobs: master, index, and leaf. Master describes what the file is, index describes what the parts of it are, and leaf are one too many different containers that contain the actual shreds that make up that file, or the chunks. With this growth, Microsoft recognized that SQL itself could start to become a constraint in many environments. So in SharePoint 2007, external blob storage was introduced. External blob storage was a very clean way to let files, when they were being uploaded to SharePoint, be redirected to an alternate location. It was a COM-based implementation, which means that there were no rules in it. So once you turned EBS on, your contents would go to someplace else, a file share, SAN device, NAS device. The core concept is to keep the content databases relatively small and let files move somewhere else. But again, there were some constraints on that. So when Microsoft moved to 2010, they deprecated support for external blob storage and brought up remote blob storage. Conceptually, the two were very much the same, except that RBS used a .NET implementation, which made it possible for third-party ISVs and people who wanted to write their own extensions to it to use a rule-based system to start determining which kinds of files we want to move out. There is a file stream provider, which comes as part of a SQL Server feature pack, which is there for you to be able, in most implementations, to take those files and move them to a file share that lives on the SQL Server itself. And the amount of shrinkage that you get in your content database is driven by how those rules are set. So if you only have a rule that says files beginning with the letter A move out, you're not going to get much shrinkage. If you're using move everything out, you're obviously going to see some massive reduction, sometimes 90 to 96% reduction in the size of the content database. Along with that, Microsoft made implementations to Cobalt, otherwise cleverly known as MS FSS HTTP for file synchronization via SOAP over HTTP protocol. The core idea of Cobalt was dealing with the fact that in a collaborative environment, users sometimes are only changing a very small bit of the document. But when a user makes a change to the document, the Cobalt protocol defined a way that the client could identify the piece of the file that had changed and move only the piece of the file back across the wire. So this definitely improves network throughput. Now, on the server side, there's a penalty that goes along with that. So let's suppose we have a 10 meg file and we've just edited a tiny bit, one character of it, and we have a very small bit of that file going back over the wire. On the server, at an I/O level, in order to coalesce that change back into that master file, the server needs to read that whole 10 meg file in, find the part that's changed, and then save the whole 10 meg file back. So 2 times the I/O for every file save. From a user perspective, things usually run faster, but it puts a heavier load upon the server. Cobalt, by the way, was also used to support file sync tools like SharePoint Workspace, and is the engine that makes it possible in 2010 and beyond for co-authoring to work. Co-authoring with multiple users for 2010, Word and PowerPoint full client, Office Web Access for Excel, and OneNote. In 2013, all those clients are supported, by the way. So those were the structural changes in 2010. What's very interesting is Microsoft put out, around the time of SharePoint 2010 Service Pack 1, new guidance on how to deal with capacity constraints in SharePoint. Because it came out the same day, many people believed that Service Pack 1 included capacity changes. It wasn't, but it was based upon Microsoft engineering tests about what would be important for content database size. Big content databases start to cause performance issues. The files are going to be the size that they are, but a 500 gig database or a terabyte database can be harder to back up, can be harder for users to work with. You start running into transient lock errors. It's very nice to be able to keep those databases small so that more of them can be in memory, so the server is going to do better cache hits for frequently requested files. So the key guidance that Microsoft provided is, as always, up to 200 gigabytes in the content database, no restraints. For 200 gig up to 4 terabytes, Microsoft support is based upon the performance of your disk subsystem. You need a minimum of 0.25 input-output operations per second, IOPS, per gigabyte of content, with 2 IOPS per gig being optimal. So for 200 gigs of content, your disk subsystem needs to be able to support 400 operations per second. And most hardware can support that and go up significantly higher. Based upon the hardware you're running on, it's a good place to model what the realistic capacity of your SQL database is going to be. And they also added some guidance as to how to use document archives. There's no IOPS rules for doc archives, but Microsoft makes certain assumptions that you're going to use Record Center or Document Center for an archive, and that you're going to make very few changes to those files and very few reads, and that you're not doing anything like item-level security or alerts or workflow. You're not collaborating or changing content in an archive. That helps support, understand what kind of performance you're going to get from those systems. Down there at the bottom, and you can download this if you need more of this, RBS use does not skip these limits. So, and if you think about it collectively, if I have a 500 gigabyte content database, or half of those contents having been moved off to a file share, the aggregate input-output operations on that server are going to be what drives user performance. So just because I've moved all the content out doesn't spare me the need to make sure that my disk subsystems are performing adequately. Most of this RBS work is driven towards archive scenarios. The idea behind this was that users are going to take files and work with them in a live database very quickly. But after users might have older versions or stuff moved to archives, you still want them there, but might possibly move them out of the database to keep the database size smaller. A couple of other bits about that. It's very important for business continuity that backup restore operations are synchronized across databases and across an RBS file store, because those two things need to be kept in sync, so we need to back them up at the same time and restore them in collection as well. Behind the scenes, RBS does not edit a blob when I make a change to a file if I'm not versioning. It just generates a new blob. You need to use garbage collection to go back and clean that up behind the scenes. And finally, no monkeying around in the database. You, as administrators of your system, should not be going in to dump files directly out of tables and try to serialize them, nor can ISVs write things directly into the database. All these things need to be implemented through code. Which brings us to the challenge that most organizations find is that SharePoint is a collaboration site. It's not just a file archive. So how can Microsoft deal with that? And the answer was shredded storage. In shredded storage, how many of you, is anyone here not familiar with shredded storage? I hope you are, because you've come to a shredded storage session. A couple of hands went up, so let's walk through a few things. Let's walk through a typical scenario. And in this case, we're going to assume we have a 100 megabyte file. When I first save that file up into SharePoint, assuming that I have a SQL content database and RBS storage configured to put things out to a SAN, the first time I save the file, I have 100 meg in the database. Let's suppose I edit 20% of those files. I'm not using RBS, and I'm not using shredded storage. The end result is I now have 200 meg in the content database, because that full change is going to be saved without shredded storage. If I turn RBS on, what I'm going to find is all of those files are going to be moved, in most cases, to my RBS file store. Now let's suppose shredded storage comes on. We're going to talk a lot about the size of the shreds, and in this example, the shred size is almost never going to be set to 20 megs, but the graphics are really, really hard if I'm using a 1K shred in this. If I edit, seriously, I tried it. It was worse than walking in front of these mics. So if I edit 20% of a file in a shredded storage-enabled environment, the end result is that I'm now consuming 120 meg of disk, because we're able to figure out what parts have changed and only save those changes. Future reads will be coalesced to return a rich experience back to the user. And if I use RBS, obviously I still keep a little bit of that data in the database to describe the file name, the permissions, and so forth. But the core file contents are moved out to SAN storage. That is fundamentally one of the ideas of shredded storage. A couple of misconceptions that are out there is that it only works on Office docs. It does not. It doesn't actually understand the structure of the file types that go through it. So it's not going to break the document up by pages or by slides in PowerPoint. It's going to look and figure out where can it partition a file most efficiently to break them into the appropriate sizes. It's taking use of the Cobalt technology for figuring out what those partitions should be. And it's there principally to support collaboration scenarios, so that if you have documents in many organizations, those highly collaborated upon documents can generate 50, 100, 1,000 versions, that you have much reduced demand for storage of those files. How many of you are using any sort of co-authoring in your enterprise? Okay, so that's always nice to hear. In co-authoring, for those of you who aren't using it, multiple users are editing a file at the same time. Every refresh can generate a save. And versioning should almost always be turned on in co-authoring environments in case one person needs to make a change that has to be backed out. Obviously, if you have 5 people on a phone call for an hour all making changes and hitting refresh, you're going to generate hundreds of versions. So this is here to help support collaboration and not just archiving. Also, because of the way that those shreds are composed, you see that we talked before in 2010 about that I/O penalty. I've got to read the full file, figure out what parts have to be slid in, and stick it back. That doesn't happen in 2013 because I'm just putting that piece of the file that goes back in. Lastly, how many of you are still contemplating an upgrade to on-premises 2013? Okay. How many of you are planning on doing database attach? Okay. Database attach is the Microsoft preferred recommended way of moving well-structured content from 2010 up to 2013, but it bears noting that your contents will not be shredded automatically for you when you do a database attach. However, if you are using any tool set which addresses the appropriate APIs to upload files, and that's usually third-party providers, all those contents will be shredded upon using those tools. So if you're using a migration utility, and every migration utility you could want is out there on the expo floor, I'd encourage you to keep that in mind. If you're trying to take advantage of shredded storage for a large volume of content that you're upgrading, that may be an answer for you. Worth keeping in mind. Okay, the crux of what we want to get through is testing and how we interpret those test results. So at the Dell Labs, the core system that we built was an i7, 16 gig of RAM with these configurations. Full disclosure, this was done using Dell's Storage Maximizer 2.5. The fundamental performance characteristics, though, that we're going to see should be consistent with any third-party provider that could be used out there. So this is information that we've talked about with our colleagues at, I'm still in pronoun transition, I'm not at Dell, I want to be clear about that, but I've spoken to colleagues at Metalogix, NavPoint, just basically checking the soundness of these results, and they're pretty much consistent across the board, although we were much more extensive in the ranges of tests that we designed. So here's some of the information that we saw. So by default, actually, this is a good one. I'll let someone have a book. I'm not sure I've said it yet or put it up on a slide. Does anyone here already know what the default shred size is in SharePoint 2013? Yes, man here. The default size for a file shred. Okay, right in the back? 64K is the correct answer. Thank you. I'll leave this here and not zap you, or you can just run on up. Let's make a deal style. So 64K is actually the top line in this, and we saw the actual worst possible performance for relatively small files with that information. We ran across a range of stress tests, and you see there's a little bit of choppiness in the data, but some of the best performances that we saw for shredded storage configuration were at around 1 meg or 1250K. Those are some of the lower lines that are here. There's always some variations in the data, but we thought that was very interesting, that making the shred sizes gave us better upload performance time. Looking at different ranges of file sizes, here's what we're looking at again for medium files, defined as things of 2 to 16 meg. And in this configuration, again, we saw some great performance much lower. There's a full table coming of all the actual tests, so you can grab some of these and pull them down. But for those of you who are shooting pictures, there's one coming up. Similarly, when we look at some of the information around RBS testing, the two things that we can configure around these two environments are how big do we want to make those partitions, those shreds, and what files sizes do we want to move off to remote storage. So for example, in looking at very large files, when the rule was set to externalize nothing, that's the 0 line, sorry, the purple line, the 0 line, is this going to, yeah, here we go. So if nothing's being externalized, this is the behavior that we're seeing. But when we set the rules to say externalize every file 2 meg or greater, we saw the performance line indicated down here. Okay? So we definitely have two different sets of configuration parameters. In those configuration parameters, these are the sum total of best results. You know, I always feel like this is a little bit like the Oscars. Best upload performance for small size in a shred is 1250K. In most cases, the shredded storage configurations that work best are 1250K or 1024. Obviously, you need to look at your own usage patterns to figure out which of these settings might make the most sense. You know, I would encourage you, and I'll have the links to them at the end, to visit Dell's website if you need to download a full set of this configuration information. And there's similar information that's out there in the community as large as well. And looking at the rules for remote blob storage, there's a little bit more variability looking at small files, medium files, and large files, both looking at them for uploads and downloads. But again, in all cases, by the way, it's worth noting that the only way that you can configure rules for RBS is with a third-party provider. There is no way in the Microsoft implementation of FileStream to start writing rules unless you're going to add to FileStream on your own. So there is no default setting as there is in the case of shredded storage. So the last thing that we did, just to kind of put this into context, is since from the first analysis we know what the best performance tended to be for RBS and what the best performance tended to be for shredded storage, we wanted to go one step further. In the first versions of SharePoint 2013 beta, shredded storage could be turned off or on. You can no longer disable shredded storage. Do not taunt Happy Funball. Okay? You cannot get rid of shredded storage. You don't want to. You shouldn't want to. There are a couple of hacks that people have found to think that they've turned it off or they've found a setting. You can't do it. You will always generate at least 3 blobs no matter what in every file save. Shredded storage is essential to that and needs to be left on. So assuming that shredded storage is going to be on, the analysis that I did was looking at the data and figuring out if we're going to use a 1 meg shred size, how does the performance of RBS or traditional SQL storage vary? And so one of the things that we found is that shredded storage itself gives us great performance gains for both file read and file write. RBS can be slightly faster for writes and slightly worse for reads if we're not using shredded storage. And in a shredded environment, and SharePoint 2013 is going to be a shredded environment, that's over here, RBS is not universally is an inefficient performer. But we need to take a look at why. We're looking at files of 1 meg or less. Where RBS really starts to shine, if you look at the data, is files that are greater than 1 meg. Shredded storage in general is faster than setting the shreds to be fairly high. But the key thing here that we're seeing is that RBS has big performance gains on large file downloads. I talked earlier about it's important to understand the composition of the files that you're looking to host inside SharePoint. It's also important to take a clear-eyed appraisal of how users interact with those files. On average, in my experience, most SharePoint implementations tend to be more read-heavy than write-heavy. However, if you're successful at setting up collaboration sites, you may find that the volume of reads and writes becomes roughly equivalent. So it's important to understand those two things. So in general, it looks like RBS definitely can give you some performance gains if you have a lot of large file downloads based on where those files are in your environment. For example, a video library or a library of CAD files or libraries of PDFs. If we can say with reasonable accuracy that I'm going to have a number of large files, we should be in good shape. The other thing I did looking through the data is what does it look like comparing the performance of RBS versus shredded storage on small files. Here what we're seeing is RBS is significantly slower on both reads and writes. If we've optimized at a 1 meg shred size, RBS is smaller, RBS is worse for small files. But again, RBS, when we're looking at files of 1 meg and up, RBS gives us essentially the same performance and is faster on reads. The other thing that's worth noting, though, is RBS has a capability that nothing else would have. RBS does, remember, give you the ability to shrink the size of your content database. In general, if your content databases are smaller, they're easier to administer, their growth rates will be lessened. So let me bring this all back around and set it into context. The best settings that we have seen, the two parameters, and we'll talk through this, how to apply those in more depth when we get to demo. File write chunk size and file read chunk size. File read chunk size was introduced in SharePoint 2010 and is being deprecated. Its default setting was 64K. File write chunk size is what tells the server what size do you want to make those files, and we saw the best performance at being at 1250K or 1024K based on the sample of files that you're looking at. In our experience, it makes the most sense to optimize files of 1 meg or greater, but for RBS. But the way that we administer that is through whatever the provider is going to be. So obviously, different implementations are going to have different ways of doing that, and I'm not going to walk through every possible RBS implementation that's out there. This is one of the things I wanted to walk through, and we'll get to it in demo. But fundamentally in PowerShell, here's how you do this. This first set of PowerShell lines you should never do. This is setting the file write chunk size to being 2 gig, which will, in theory, make it hard to shred most files, because most files in SharePoint are going to come in at less than 2 gig. Bill was talking earlier in the week also about some of the reasons why that's bad, and we'll talk to it. I'll speak to that in a moment when we talk about Sapphire. So, in general, you may play with those to your heart's content, but the absolute max value you'd ever want to put out there for a write chunk size is 4 meg. You can have real problems if you set that value to be greater. You also should never set it lower than 64K. 64K was done by design. File write chunk size, moving forward, is the parameter that Microsoft is going to use for figuring out on the server backend when it can most efficiently pull files out of a database into its own cache. So that's the most important configuration out there. File read chunk size, although Microsoft has published recommendations, it's been deprecated. My guidance to you is to ignore this parameter. So Sapphire is an interesting protocol. Sapphire began with Windows Vista, and it's carried forward into all versions of Windows, up through and including Windows 8.1. It's a native SOAP stack for handling file requests, and it caps the file size that's going to come down in a protocol envelope at 3 meg. So there's a fundamental problem. If I were to set the shred size to 1 gig or 2 gig, and the clients, and they may be web browsers, and they can be copies of OneDrive for business and so forth, if the clients are only going to be pulling files down in 3 meg intervals, and the server thinks I have to go get a gig or 2 gigs every time, if I have to pull a number of small files, if I'm only pulling, let's say I have a 9 meg file, and the client's going to ask for 3 protocol envelopes. It's going to ask for, it can't get any more than 3 meg, so it needs to have essentially 3 packets come in. But the server thinks it needs to go get 2 gigs in every one of those things, so you're going to pay a huge I/O penalty by having that size set that high. That's part of the reason why we say 64K was chosen by default for Microsoft based on its assessment of average file sizes. We see better performance with shred size moving to 1 meg and up, but I wouldn't go beyond 4. So to kind of bring that back home, obviously shredded storage has significant advantages to traditional storage for both speed and slowing the growth rate of content databases that support collaboration. RBS seems to have a little bit less value for files of 1 meg and below, but above, absolutely clear indications in our data, and also consistent with what we've seen with other vendors, that there are significant performance gains on file downloads. Only RBS provides a means to keep your content databases small. So shredded storage alone does nothing to keep those content databases small. This is a question I've had a number of times out in the field. People will ask, well, if I have shredded storage, does that mean I don't need RBS? And the answer is absolutely not. If I have 500 gigs of files in SharePoint and I shred them, I still have 500 gigs worth of shreds. In fact, I probably have about 520 and 530 because there's some inefficiency about where the slices happen. Now, it's true that shredded storage may mean if I go back in a year and look at the growth from versioning, it may only be 700 gigs instead of 1.5 terabytes. But only RBS keeps those databases small. The other thing is that RBS performance usually means, since you want to be selective about what files move and don't move, that either you're going to write your own provider, which is not recommended, or you're going to go buy one. And if you want suggestions from me, I'm not going to do them here from the stage. I'd encourage you to go out to the show floor and talk to any of the usual suspects. I hate suggesting any because I'll always leave one out, but that's what's going on there. Okay, some other performance tuning on SQL that's worth taking a look at. Back in my consulting days, this was the core worksheet that all of our field consultants would use to assess disk size for on-premises implementation. My master's degree is in quantitative finance. My good friend Mike Gilronan has noted that Chris McNulty has never met a whiteboard with Greek letters he doesn't love. So I'm not expecting that we're going to sit here and work through all the math here, but the fundamentals of this are talking about the fact that in SharePoint, whatever content size I have, we need to make some sort of attribution for user collaboration and for a growth rate. In SharePoint, we also have the opportunity to crawl content that isn't in it. Frequently, I'm asked by organizations that say, hey, we have a bunch of stuff that's been sitting around in old file servers, and we want to bring it all up into SharePoint. When the discussion becomes how much information do you have, sometimes it's, well, we have 60 terabytes of content that we want to put into SharePoint. Well, what's in that 60 terabytes? The answer is, well, it's a bunch of old archive stuff that no one ever looks at anymore. The best answer is usually, well, you don't want to build a disk subsystem to support 60 terabytes of content databases. You really don't. So let's do some analysis and figure out what parts you do need in SharePoint, and let's keep the other stuff where it is and just go search and crawl it. It's also important to remember that in search and crawl, you're going to also add to your data storage needs. Microsoft guidance is to expect about 30% of the files crawled should be represented somewhere in the content database. Real-world experience is significantly less. Sometimes it's 2 to 3%. And so in our assessment, we usually were expecting about 0.5. Rather than walking through all the rules of disk sizing, just content's going to grow. Searching remote stores saves disk, but it's not free. This third one is really interesting. I've had, there's one organization, I won't name them, that believed that they moved to RBS for a very large, they had 10 terabytes of data. And they wanted to bring RBS in because they didn't want a 10 terabyte content database, but did not understand that that 10 terabytes had to go somewhere. Just because you would only wind up with a 100 gig content database, you also have 9 terabytes of files that need to sit in the sand somewhere. So RBS is not a shrinkage of the total pool. It's just moving things, again, from the database to somewhere else. And shredded storage, again, does not reduce the overall storage needs. It really slows the growth rate and obviously offers performance gains in how those files are processed. SQL, as I mentioned before, is fundamentally driven by disk I/O. And we don't have the time today to work through a heavy session on disk layout and design, but fundamentally remember, when I'm looking at physical disk subsystems, there are 3 types of disk things I want to look at. In RAID 1, I have mirrors. So I have one disk and a second disk alongside of it. It's a very expensive way to build continuity, but it's relatively reliable. RAID 5, parity. So For 3, 5, 7 disks, I'm always calculating a checksum bit on a save. So this pool, if these were 5 100 were each 100 gig disks, this would give me effective capacity of 400 gig with the 5th disk being fail. I can lose any disk in this array, and I'm fine. But there's a performance penalty because every time I write data to it, I have to do a calculation. RAID 10, RAID 1 plus 0, RAID 0 plus 1. Storage engineers will fight me over the proper way to call it, but I just call it RAID 10. Stripes of mirrors are mirrors of stripes. All the data is written twice at 2 places in the disk, but there is no in the disk array, but there is no parity bit. So this is super fast and super expensive because you're buying twice as much disk. One of the best ways to assure that you're getting optimal I/O performance is by using high-performing disks. RAID 5 may not be a high-performing disk in all environments. So it's important to look at, in a SQL environment, where are you putting your data files, log files, temp, and the backup files. The key goal there is to get more physical disk elevators working on every process at every time. Part of the reason why RBS does help is it is offloading the processing, in most cases, to a different disk subsystem. There are some other tests that have been done about what does it look like when RBS is being moved to somewhere across a network, or those files are being moved to someplace across a SAN fabric. Now, there's unpredictability in that because you're driven by network throughput. But in those environments, if I have one set of disks here that's holding up my SQL server and a different SAN array, and I'm RBSing my files over there, I'm getting a lot more workers working on my processes. So the more I can isolate those physical realms, the better performance I get. So in general, if you can, it is ideal to have separate disk subsystems for data, for log, and hopefully for backup files. I would love to tell you that you should stick RAID 10 everywhere, but it's expensive. So sometimes the performance trade-offs is boot disks get RAID 1, log files, which are the most data-intensive and most high-performing requirements, log files and temp files should go with RAID 10. And if you have to compromise somewhere, your content databases could go in RAID 5. One thing very much worth noting, when I save a file up to SharePoint, it does not ever go directly to the content database. It first lives briefly in TempDB. So the behavior and performance of TempDB has a lot to do with how long it takes a user to save a file. And although a single user experience doesn't affect anyone else who's using SharePoint at the same time, over time that can really start to it's one of the big predictors of why users think SharePoint is slow, because it takes too long to save a file because TempDB is sitting on the C drive with a bunch of other things that are thrashing around. Physical isolation extends to virtualization. I'm going to talk a bit about virtualization by saying if you're using VMware or Hyper-V for SQL, I really don't like doing it. But if you are going to use that, please make sure you have dedicated physical disks for data storage. Why? If all of my SQL environments are using virtual disks, they may all be just all hitting the same physical disk array. And you're going to see a performance bottleneck on the physical side of that information. We talked about RBS. We talked about how it's important to measure IOPS. We'll take a look at that in just a few moments. Other things to optimize your SQL configuration. It's not a performance thing, but please use SQL aliases. Please, 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 please. I have many, many, many frantic emails from people saying, I'm moving to a new SQL server. How do I move SharePoint config and rename all the databases? If you've used aliases, no problem. Just point the alias to your new server. Otherwise, for all intents and purposes, there are ways to do it, but you're going to be dropping and rebuilding the environment. Auto create statistics is an option. Please don't use it in SQL Server. SharePoint sets the query hints out there. And also, MaxDOP, maximum degree of parallelism, determines how many queries can run in parallel on a processor stack. It should be set at 1. If your SQL environment is set at 0, that means you're telling SQL, go to town, figure out your own SQL ways of optimizing queries, but SharePoint knows the right way to submit queries in the right sequence. So you're going to slow the system down if MaxDOP is not set at 1. In general, compressing backups also saves disk. One of the single biggest things that causes downtime in enterprise SharePoint environments is filled disks. They can be easily recovered from, but big backups are one of those things. Also, transaction logs. If you set ModelDB to simple mode, all future databases created there will be made in simple mode, so a full transaction log will not be generated. There are pros and cons of using transaction logs. A transaction log, again, makes it possible to do a point-in-time recovery. But transaction logs are notoriously finicky, in my experience, about being backed up, and they can also fill up disks. Some things like SharePoint config can generate proportionally large T-logs. You don't actually need them. You're perfectly fine having that in simple mode. And in truth, it's rare that you would be doing a recovery against those environments themselves. SQL is very good at handling its own memory, and will go grab any memory it can see in any environment. In general, if you want to set a cap on it, it's good practice to cap it to about 90% of what's available, just to make sure SQL doesn't ever, if it has a runaway or a bad process, go grab all the memory and leave you unable to log into the system without forcing a reboot. Where are we? There we go. And when we're looking at some information, if you ever look at an environment and see the IOPS are coming in at less than 400, we need to do something with disk I/O. Or we need to reduce content database sizes. When we go to demo, the cloud environment I'm showing you on is performing relatively well today. Some days it runs at about 70 IOPS. 70 IOPS would predict a content database size of about 35 gig. I'm going to show you a free tool called Iometer that you can use to measure input-output performance. It can also be extrapolated from looking at performance monitor statistics. And if you're seeing disk average reads or writes of greater than 15 milliseconds, if you do the math, that translates to about 67 IOPS. So if you're ever seeing these times going up in your environment, you definitely have an issue. Okay. And lastly, don't virtualize SQL. SQL is an aggregation environment. There are some cases to be made for virtualizing test instances or dev instances of SQL. But production instances of SQL, best performance is going to be by putting them on physical hardware. There's guidance that's available on TechNet if you do virtualize SQL for what needs to be done to get at least decent performance. Okay? Now let's take a look at demo. And if I have given the right offerings to my demo gods, this should all come up and running. Hello, demo gods. And kick over to 7. Lo and behold. Okay, so the first thing I wanted to show, let me see if I can, what I'm going to do, just to make that a little bit better, just to show you what I'm going to run. So this here, this bottom line, I actually, when I zoomed it kind of went fluey on me. So this is all we need to do to set the shred size. Here I'm setting the shred size to the default. I just go get a handle to my web app, and I set the chunk size and use update. Relatively simple, relatively SQL. So just to walk through that, this first example here, and I know this is hard to read, that's why I blew it up. As always, we need to make sure the snap-in is there. We're going to go run this command. And this command is in bytes, represents 1024K. So this is applying the shredded storage optimization that we determined based upon our test that we want to have running in that environment. Relatively straightforward way of doing that. The other thing I wanted to show you is a tool called Iometer. Iometer is available. It began as an HP project and is now on SourceForge, as it has been for about 8 years. Totally free, not being maintained anymore, but it's a utility that you can download. It's relatively small. It allows you to do some level of stress testing on your environment. So let me drag this and blow it up a little bit for you. So one of the things that Iometer will do when you're running it is it lets you play it and simulate a fairly extensive load. One of the problems with using Performance Monitor to extrapolate statistics is you have to be looking at the system under a time of stress to figure out what the maximum capacity of the environment is. This will stress your system. Iometer is going to need to be used in production hardware if you're trying to measure the hardware, obviously, but should not be done during a time of production usage, since it's going to max out a lot of the I/O in the system to figure out where the bottlenecks are. It'll also generate target files and the target disks that can consume a large amount of disk space and need to be cleaned up afterwards. So again, don't do this at 10 in the morning on Monday. And if you do, please don't call Microsoft and tell them that Chris McNulty said that it was fine to do that. So on my environment is poorly configured. C is the only drive for everything, so C is the target. And I'm also going to pick, you have a range of access specifications here. Let me zoom that up for you a bit. So I can pick, do I want 4K read, 4K with 100% read, get some random mixing in there. There's some default settings. You just figure these, lo and behold. I'm going to say there's an all-in-one test. Let's remove that. Let's go just take a default, which is a random bucket of tests. We tell it to start. It offers the possibility of saving the results out to CSV. And it starts going. We come here to results display, and let's tell it to update every 3 seconds. And we see that this system is behaving, at the moment we sampled it, at about 718 IOPS. Or roughly speaking, we could put 350 gig of content into this environment and still be within Microsoft support constraints. If we had come on the system and it was showing 71, it would tell us that we had a problem. Even though a small content database would still be supported by Microsoft, you should never see that kind of disk system. Most locally attached arrays are going to give you hundreds of IOPS per second, but the actual performance may vary. The last section of the demo I wanted to just walk through with you is where you go, because this is one of those things that you usually do during installation and then have to scratch your head like, I know where it is, I know where it is, I know where it is. So I wanted to just give you a quick walkthrough to where to go in Management Studio to set some of those settings that we talked about earlier. So I've broken out Management Studio here, and I will blow this up once I pick the setting. Most of the things I want to do, by the way, my SQL Server supports 2 SharePoint environments. It is a best practice to not install multiple SharePoint builds into the same SQL instance. Same hardware, 2 instances. One is supporting a SharePoint 2010 build, one supporting SharePoint 2013. Part of the reason for that, and I'm getting on a soapbox here that's not directly related to shredded storage, it's got to do with those databases. It becomes a lot harder for maintenance things to figure out what information is going into which databases, if I have 2 databases with very similar names and long GUIDs next to them, or which one is SharePoint config, part of why we keep some isolation there. So I'm going to go in and just take a look at those settings by highlighting the server and under Properties. For example, maximum degree of parallelism, maxstop. Here, it's right under the Advanced Settings. Right here it's set at 1. If you come in and see this environment is set at 0, you're going to see great performance gains by going in and setting that at 1. Come back. Database settings is where I go to look at backup and configuration things. So here under database settings, I can see I have told SQL by default you should compress backups. Most backup files are compressible. However, if I'm doing a disk dump, and most SQL databases are relatively sparse. The blobs can be big, but the rest of the information, not so. You will reduce your disk space usage and get better performance and uptime if you compress your backups. And that's really the core of what I wanted to walk through. Almost any of the settings that we're talking about in this can be done through SQL Enterprise Manager here. So that said, let me get back into main session. Okay. Office 365. I I hadn't planned on including this until I knew what Microsoft was going to be able to disclose. There's really two places that shredded storage comes to bear, which were both covered in the keynotes earlier in the week. One is Fort Knox. Fort Knox deals with shredded storage at the Office 365 level with encryption. So the idea of Fort Knox, I have a slide to explain it again, but also the announcement that we've now gone to a 1 terabyte site collection limit in Office 365. Microsoft was able to make significant enhancements over the last few months to the Azure storage framework that sits under all of their Office 365 builds around the world to give the kind of disk performance where having a content database on their side of 1 terabyte is supportable and scalable. So that's where Microsoft has set up the 1 terabyte site collection limit. If all of the stuff that we've been talking about configuring shredded storage and RBS and the like, is too much for you, Office 365 promises a simpler way of handling these sorts of things. Office 365 also includes something that you realistically are not going to be able to do in your environment, and that's dealing with secure shredded stores. SQL blobs by themselves are not encrypted. If you actually take the contents of that column in the database, which you're not supposed to do, a SQL administrator can go in and read the file. Shredded storage provides some protection against that because each bit of that file is going to be broken into a separate shred. So someone could, in theory, write each of those objects into a variable and concatenate them and rehydrate the file on their own if they chose to, but it becomes much harder. Secure shredded storage on Office 365 solves that problem. So if our file here has been broken up into 64K chunks, which is the default setting in the service, each of those is given a separate partition and a separate encryption key and is written on the back end to different databases which run in different data centers, and only 10 people at Microsoft have the key to that environment. They have a complex of rotating data centers and for where the keys go to make sure that they're both redundant and not all in the same place. So someone asked me a question out on the floor this week, is it possible to configure Fort Knox for on-premises? And the answer is, I suppose. It's not it depends. It's, I suppose, if you were willing to make that investment in a rotating arsenal of disks and data centers and build your own PKI system for handling those sorts of things, but there's a huge hardware infrastructure that's underlying this that Microsoft has already invested in so that you don't have to. And with that, this picture tells me that we have come essentially to the end of our session. So we have a little bit of time for Q&A, and I will be up here to take those shortly. But as we're kind of rounding the home stretch, a couple of references I wanted to put there. And again, download the deck if you need these. Microsoft's own RBS testing kind of is the grandfather of all these sorts of things. The work that Dell Software did was available up there, as well as some similar discussions from AvePoint and Metalogic. Chris Givens, who was co-presenter with Bill Baer and a good friend of mine, also a SharePoint MVP, has a shredded storage testing framework and documentation that's available out there. And lastly, Iometer, should you choose to run it on your own environment, available free at iometer.org. So I'll be here for questions, but again, best place to get in touch with me is either through my email, chris.mcnulty@yahoo.com. There's my blog, my Twitter handle, or you can find me at any of these lovely events coming, hopefully, to a city near you. I'll be at the Microsoft Exchange Conference down in Austin later this month, as well as a few other events around the world over the next few things. It is a real honor to be here at SharePoint Conference again. Thank you very much. Please be kind in your evaluations. Sure, since you asked. Thank you. Thanks. Hi. Hi.
Thanks for the session. It was really good.
Fantastic.
Were you first? Go on.
So I'm curious about the Max DOP.
Yep.
I also handle the SQL Server side.
Yep.
And then we usually want to put it to zero, so you make sure you use all the cores.
So for those of you who are sitting in the room, if you don't mind, I'm going to repeat the questions. The question is about why wouldn't you want max stop to be set at 0? The reason, why would you not want it at 0? At 0, SQL may start to move pieces of those queries in the order that it thinks are important. the thing is, SharePoint provides the query hints itself in the queries that it sends over. So the extra thrashing that you would get from max.0 is a waste of time. It should be set at max.1 because the SharePoint queries will come in pre-optimized. That's why max.1 gives. Otherwise, any other things that SQL thinks it is going to do are getting in the way of what's a pre-optimized behavior. SQL is very smart, except when it comes to SharePoint. Because sometimes you can play a lot with query hints and query analyzer and setting your own SQL indexes on what SQL thinks it should do. The catch is all of those things just slow it down because SharePoint's a Microsoft product and it was built with its own indexes and query logic to go into it. Okay.
Because the sequence of events that the SharePoint is querying is like kind of sequential and you can parallelize it.
Yeah, I mean, and part of it is maxstop is, and setting maxstop, letting maxstop be high is great if you have a very small number of queries happening at any moment in time. That is not SharePoint because of the high user demand and because, in fact, every page load is generating dozens and dozens and dozens of select statements. Lots of queries are going in. maxstop is pre-optimized to work with one on SharePoint. And in fact, the way over the years, SharePoint today will not install on a server that has maxstop set at anything but one. Okay?